Hello everyone. Uh, in this video, I'm going to walk you through question Q19 of part 1 of the RF technology homework exercise. The question has two parts. The first part is about a waveguide with the EX given, the electric field in the X direction. So I presume the direction of Z is the direction of propagation. So the question asks for the mode of propagation. Remember, whenever you are asked to work out the mode of application, you need to look at the expression of the yeah of the electric field. It doesn't matter whether it's in the x direction or y direction. You have to look at this. Okay. Um, It also asks for the frequency of operation. So in order to know the frequency of operation, you need to know the cutoff frequency. And the few components of XZ and E of Z. So we are going to work this out. So I'm going to switch you back to the whiteboard mode. So here we are looking at the whiteboard. So first of all, the question has already given us so Q19 part 1. A is equals to 1.2 centimeter or simply 0.012 meter. And EX is equals to 10 sine 2. I think there's some misprint. There was some misprint in the question, right? Originally, the question has omega here. But I think we need to delete it. I don't think it will be right. So omega t and then 150 and then z. So there are two pieces of information you can get from here. First, this one is always k of z. And this one should be equals to n uh, pi pi a. Yeah, I think there's something wrong here. Yeah. There should be a pi here instead of omega. So in this case, how about m? M is so trans is that m is equal to 0. Yeah, first, uh, if you do partial y is equal to 0, but e of x is not equal to 0. So this means partial y is 0. So this is the first piece of, sorry, sir, partial x. Partial x. Yeah, I got it wrong. Partial x is 0. So we confirm that partial x is 0. And now we need to look at the formula. E of x can be calculated using this formula. V and then ex minus omega and then So clearly, this term is 0 because it has partial x. Uh, and from here, we can conclude that it is minus omega kc squared, and then y. So in this case, we confirm that Ex is log 0. Then according to this equation, uh, the electric field in the y direction is log 0. So in the direction of propagation is log 0. The um, the longitudinal electric field is log 0. So this means uh, is TE mole. Is a TE mole, and M is 0 because there is no x direction. And N, yeah, what is N? Right? We can go calculate from here. 2 pi y over A. And this is supposed to be N pi y over A. So this means N is equal to 2. So as a result, we conclude that in the part A of the question, we conclude the mode of operation is TE and then 0 2 mole. Mn, yeah, 0 2 mole. So this is done. So you have the mole information. Then you can work from the mole information to get the cutoff frequency. In order to get the frequency of operation, you need to know the cutoff frequency. If you don't have any information about the cutoff frequency, then you're not going to get anywhere. Okay? So, and part B of the question. Part B. I'm going to erase this part. Part B. So we are going to use this information TE02 to work out the, uh, the cutoff frequency. So TE02 is the mode. And KZ is equal to 150. So this is very important. Yeah. Now what we are going to do is to use the formula for the cutoff frequency to for the propagation constant to calculate the cutoff frequency. Okay, so this one is the best. K 1 minus Fc over F. So this is the frequency we need. And as a result, we can plug in and then K. K is 2 pi F and then the speed of light. And then 1 plus Fc. We can't do that. We cannot do that. We just work out the cutoff. So Fc is equal to V phase divided by 2. And then M uh, m pi over a plus n pi over b. So we are going to use this formula to work out the cutoff. Actually, it's m over a, not m over a, n over b. So we got uh, b times 10 to the power a, 2, and then 0 plus 2 over b squared. B is equal to a, so we are going to substitute here 0.1012 square. So let's see if you can get anywhere. Okay, we got 25 gigahertz. So now the second part of the question. Let's check. The second part of the question is to calculate the frequency of operation. So it's very simple work. You just need to know the K. So K V is equal to K, and then 1 over Fc over F. So this is the frequency you need. And as a result, we can get 150 is equal to 2 pi F over C. And then 1 plus 25 for F and let's see what frequency you get. So by working out here, let me check. Let me check with the 150 is equals to 2 times pi times F, and then divided by C, and then times square root of 1 minus 25 gigahertz and divided by F. Okay, so we are going to solve it for F. So I got 26 gigahertz. 26 gigahertz. So apparently this is the answer, close enough. Yeah, let's check the final part of the question. The electric field of H of Z and E of Z. You already know H of Z is not zero. E of Z is zero. So we can now focus on part C of the question. In the part C of the question, you need to use the formula. The formula that I highly recommend is this one. Now this term is zero because partial x is zero according to the question. So we have only left, what we have only left is here, only uh, minus omega z, um, and then k of z, and then partial x, and then g of x. So from here, you can just assume that h of z is equal to kc square and then omega, and then integrate dx and then dy. Okay, so this is the approach I would use. Uh, and k of z is 2 pi fc and then square and divided by c, and then omega like this, and then the jet field, which is this equation, 2y 2 pi y, and then a, and then the other expression I suggest, um, don't think it's really matter, omega t minus 150 d, and then dy. So you just need to integrate this term. Uh, so minus 2 pi fc and then square and then c and then times 10, and then integrate of sine is equals to cosine, but you have to have a minus here. So minus and this minus, and then you need to do pi y over 8, and somewhere here you need to multiply one more time. 2 pi 8, and then the sine omega t minus 150. So this is the way how we get the equation. So, and if you do it very carefully, let me see. So this is e of y. So according to the question, h of z should be 25. Yeah, if you calculate the value here, you will get 25. I hope this is what you are going to get. And it's minus, minus. minus. I got a minus sign here, but the model answer doesn't have a minus sign. The cosine y is correct. And even, maybe, no? Oh, they try to change it to cosine, and this is the reason. Okay, so anyway, This is the way how we solve the problem. Okay, so now this is the part C of the question, uh, and if you calculate a big chunk of the equation, you will get minus 25.3, and then cosine 2 pi y over 8, and then we integrate cosine and we put 0 here. I still get sine and add both sides. Oh, this is the reason. So we just need to do this. Omega t minus 1 to 0 t. So this is the version of the answer. Okay, now we are going to switch to the last part 2 of the question. I'm going to switch you back to the presentation mode. Now, the other part of the question. Here we go. So we are looking at let's see. Yeah, I cannot see the. Okay, we are looking at this question. Uh, let's highlight this in both one. Uh, yeah, we are given an air filtered uh, waveguide. The dimension is 5 by 2 centimeter, and the frequency was uh, 15 gigahertz, and you have EX equal to this one here, and find the mode of operation. Oh, this question is super easy. The mode of operation can be seen from the question. Okay, so we are looking at part 2 of the question, and A is equals to 5 cm, and B is equal to 2 cm, and then E of Z is equals to 20 sine 50 pi y, and then sine 40 pi x, and then e to the minus 3 beta z. So this is the electric field, and the mole number we need to. Okay, I'm going to switch you back to the right part. So this is the given the information. You need to find the mole number. So my suggestion here is you just need to look at the original expression for the longitudinal electric field. The original expression is sine and then 2 pi ya, sorry, 2 pi ix, and then sign. Let's see. Um, it should be m by x, and then n pi y, then p. And both of them are cosine, sine. Okay, so a m, and so this is the formula. So if you just compare the given information with the original formula, you will get m pi x over a is equal to 40 pi x. So this is going to make your life easy. So you just substitute a is 0.05, and then 40, and then x. And from here, you will get m is equal to 40 times 0.05. So you get 2. Okay? Now, uh, and if you compare this term with this term, n pi y over b, b is equal to 0.02. It is 50 pi y. So from here, you will get n is equal to 50 times 0.02. So the answer here is 1. Okay? So based on the information here, you should have enough. Now also, Ex is not 0, so F is 0. So this means the mode of operation is TMO. And with this in mind, so we get TM and then 1 more. So this is the answer. Okay. If you have any question regarding any issue with this question, you just leave your comment to the comment section. Anyway, thank you very much for attending this video lectures. Thank you. Bye bye.